Hey everyone, welcome back to the channel. Look up, well, not right now, but you know what I mean. Up there in the sky is this giant fiery ball we call the sun. We see it every day. The sun is a star. Now that sounds simple, right? It means that the familiar golden orb in our daytime sky is the exact same kind of object as the tiny twinkling pinpricks of light you see in the dead of night. The only difference is distance. It's a nuclear furnace, constantly converting matter into energy in a process called nuclear fusion. Let's talk about weight, or more accurately, mass. You'd have Jupiter, the king of planets, Saturn, the rocky inner planets like Earth, all the asteroids in the asteroid belt, every comet in the Oort cloud, every moon, every speck of dust. You pile it all up. Now, on the other side of the scale, you put the sun, because the sun, that single star, contains 99.8% of all the mass in the entire solar system. We think we know what hot is. The boiling point of water is 100 degrees Celsius. Lava from a volcano can reach about 1,200 degrees Celsius. The surface of the sun is a blistering 5,500 degrees Celsius. But all of that is like an ice cube compared to the sun's core. Deep in the heart of our star, we're talking about a temperature of over 15 million degrees Celsius. At 15 million degrees, you have plasma, a fourth state of matter where electrons are stripped from their atomic nuclei. This is the environment where the magic happens, where the sun's energy is forged. Here's a fun thought experiment. If the sun were to suddenly, magically just vanish, poof, gone, what would happen? Well, for a while, absolutely nothing. We on Earth wouldn't know about it for 8 minutes and 20 seconds, because that's how long it takes for light, the fastest thing in the universe, to travel from the sun to us. So, when you look at the sun, you are always seeing it as it was 8 minutes and 20 seconds in the past. The sunlight that is currently hitting your face left the sun before you started watching this video segment. Like people, stars are born, they live out their lives, and eventually, they die. It all began about 4.6 billion years ago. There was just a vast, cold cloud of gas and dust floating in space, a stellar nursery. Finally, about 4.6 billion years ago, the core reached that magic temperature of 15 million degrees Celsius, and nuclear fusion ignited. We've talked about the sun's immense mass, but let's dig into what that mass does. It generates gravity, an immense amount of gravity. It's this gravitational force that acts as the master puppeteer of the solar system, holding everything together. Think of it like placing a heavy bowling ball on a stretched-out rubber sheet. The bowling ball creates a deep well in the sheet. Now, if you roll a small marble nearby, it will follow the curve created by the bowling ball, falling into an orbit around it. The Earth is constantly falling toward the sun. But because we also have a tremendous sideways velocity, we continually miss. When we look at pictures of the sun, it looks like a perfect, solid sphere. It has a defined edge, what we call the photosphere, which is the visible surface. But if you were to somehow fly a spaceship to the sun, you wouldn't be able to land on it. There's nothing solid to land on. As we touched on before, the sun is composed almost entirely of plasma. This isn't just a fancy word for hot gas. In a plasma, the intense heat has stripped the electrons away from the atomic nuclei, creating a sea of charged particles. This plasma nature is what makes the sun's surface so dynamic and violent. The surface writhes and boils like a pot of water. The sun isn't always the calm, steady provider of light we imagine it to be. Because it's a giant ball of magnetized plasma, it's prone to violent outbursts. The sun's magnetic fields are constantly twisting, stretching, snapping like cosmic rubber bands. When these magnetic field lines get too tangled and suddenly realign, they can release a tremendous amount of energy in an event called a solar flare. Sometimes they are accompanied by an even more powerful event called a coronal mass ejection, or CME. A CME hurls billions of tons of plasma from the sun's corona out into the solar system at millions of miles per hour. If one of these clouds of charged particles is aimed at Earth, we can have a real problem. Our planet's magnetic field protects us from the worst of it. But a powerful CME can still wreak havoc. When a CME slams into our magnetosphere, it can trigger a geomagnetic storm. These storms are what cause the beautiful auroras, the northern lights, the southern lights. But they can also be dangerous. They can induce electrical currents in power grids, potentially causing massive blackouts. They can disrupt radio communications and damage the sensitive electronics on satellites that we rely on for GPS, television, weather forecasting. The sun's temper tantrums can have very real and very disruptive consequences for our modern, technology-dependent civilization. We know the sun won't last forever. While it has a good 5 billion years of fuel left for its current stable phase, its end will be spectacular and devastating for the inner solar system. As the sun runs out of hydrogen fuel in its core, the delicate balance between gravity and fusion pressure will be broken. The surrounding shell of hydrogen will start fusing. That shell burning produces huge outward pressure. The sun's outer layers will expand dramatically. The sun will swell into a red giant. It will grow so large it engulfs Mercury's orbit. It will also engulf Venus. Scientists debate whether Earth will be swallowed too. Even if not, it will boil away our oceans and bake Earth's surface into a barren, lifeless rock. This red giant phase lasts a few 100 million years. Then the outer layers drift away, forming a glowing planetary nebula. The hot, dense core remains, a tiny white dwarf slowly fading over trillions of years. It's a dramatic, definitive end to our star. After all this talk of the sun's immense power, incredible heat, and system-defining gravity, it's time for one final, humbling dose of cosmic perspective. Our sun is, in the grand scheme of things, perfectly average. It's just one star. One single solitary star in a galaxy that contains over 100 billion other stars. Some estimates put that number as high as 400 billion. Our sun is just one of them, tucked away in a quiet spiral arm called the Orion Arm, about 2/3 of the way out from the galactic center. There are stars out there that are hundreds of times more massive and millions of times brighter than our sun. And our galaxy, the Milky Way, is itself just one galaxy among an estimated 2 trillion galaxies in the observable universe. 2 trillion, each one filled with its own billions or even trillions of stars. When you truly grasp that scale, it can be both terrifying and exhilarating. It reminds us of our own cosmic insignificance, but it also fills us with wonder at the sheer vastness and richness of the universe we are a part of. Our sun may be ordinary on a galactic scale, but it's our star, and it made our existence possible. And that makes it the most special star in the universe to us. And there you have it. From its mind-boggling mass to its ultimate fate as a white dwarf, our sun is a place of endless wonder. It's the anchor of our solar system and the engine of life, but it's also just one of countless stars scattered across the unimaginable expanse of the cosmos. Every time you step outside and feel its warmth, you're experiencing the energy from a nuclear furnace 93 million miles away. It's a connection that ties us to the very fabric of the universe. I hope this journey has given you a newfound appreciation for that brilliant star we see every day. What was your favorite fact from today's video? 8-minute light travel delay? Sheer scale of the sun's mass? Dramatic red giant future? If you enjoyed this deep dive into the cosmos, please consider giving this video a thumbs up and subscribing to the channel. Thank you for your curiosity and for spending your time with me today. Keep asking questions and never, ever stop looking up.